What is GAN mode collapse in generative adversarial networks? Imagine trying to teach a robot to paint a variety of pictures, but it keeps drawing the same face over and over. That's similar to what happens in a generative adversarial network when mode collapse occurs. In a GAN, there are two neural networks working together, the generator and the discriminator. The generator creates fake data, like images or sounds, while the discriminator tries to tell real from fake. They compete in a game to improve over time. But sometimes, the generator gets stuck and only produces a few types of outputs instead of capturing the full range of data. This is called mode collapse. Think of it like a chef who keeps making the same dish because it's easy to fool the taste testers. The chef ignores other recipes and flavors, so the menu becomes very limited. In GANs, the generator might produce nearly identical images or samples repeatedly, ignoring the variety in the training data. This reduces the usefulness of the model because it doesn't reflect the true diversity of real-world data. Mode collapse can happen in different degrees. Sometimes the generator produces almost the same output every time, which is called complete collapse. Other times, it makes a few different types but still not enough variety, known as partial collapse. Several factors can cause this. If the discriminator becomes too strong or overfits, it forces the generator to focus only on a narrow set of outputs. Also, if the generator doesn't use the input noise properly, it might ignore the variations and produce similar results regardless of the input. Training dynamics play a role too. When both networks exploit each other's weaknesses, it can lead to the generator settling into producing only a few types of outputs. This is problematic in applications like image synthesis, where diversity is key. For example, generating different faces, objects, or scenes relies on the model capturing all the variations in the data. If mode collapse happens, the generated content becomes dull and less realistic. To fix this issue, researchers try different strategies. They tweak training methods and network designs to make learning more stable. Some use special versions of GANs like Wasserstein GANs, which encourage better diversity. Others add regularization or loss functions that promote variety. Adjusting how the discriminator learns can also help prevent it from becoming too confident too early. In the world of artificial intelligence and ethical considerations, mode collapse shows how hard it is to create models that fairly representing complex data. If a model only produces a narrow set of outputs, it might overlook minority groups or rare cases, raising fairness concerns. Understanding mode collapse helps improve tools like ChatGPT, DALL-E, and Midjourney. These systems depend on diverse and rich outputs to be useful and trustworthy. Recognizing and addressing this issue is a step toward making more reliable, fair, and creative AI systems that better reflected the world around us.